Participants are ringing in for Nikki and Steve. You can actually see the participants popping in. We're up to 56 people. I'm probably live. Y'all can see me, I'm guessing.
I got 80.
Because I'm showing the, yeah, I got 80 now too. I'm showing the recording screen. For those of you who are on already, look, Armando Cabo's on there. Austin
Yeah,
Dixon.
that's a surprise, huh?
Yeah, we got some friends on already, Steve. That's cool. I love it. Guys, we're going to give it like another 1 minute-ish before we kick it off, just because everyone's still, I see the numbers ding, 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 climbing in here. And then I'll do a proper introduction of everybody and we'll get going. We've got a 6-hour webinar, so we'll be finished at no later than 9 p.m. I promise you'll be there for a late cocktail hour for your house. Just kidding.
Who doesn't like talking about psychometrics for 6 hours? Come on.
Oh, psychometrics for 6 hours. That does sound great, doesn't it, Nikki? For those of you just joining, we're going to give it about 30 seconds here. And then we are going to jump in, and happy to see some friends on. I'm seeing quite a few names that I recognize. I really appreciate y'all joining us. We're going to wait, say, 15 more seconds. I'm still seeing the number go up. Got 165 people on so far. Guys, thanks so much for joining us. I'm looking at just hitting 302. Why don't we go ahead and kick it off? Y'all ready, Nikki and Steve?
Yes, sir.
Yes, sir.
All right, friends. Thank you for joining us today. We are talking for an hour on nothing but dehumidification. Now we're going to get into some other topics and some good nerdy building science. But just for logistics before I introduce the rest of my panel for us, the best place to post Q&A is going to be on the bottom of your screen. You're going to see a Q&A tab on there. And as the questions come up, you'll see those questions kind of stack up. And we're going to leave at least 15 minutes, maybe 20 minutes, depending on how many questions I see stacking up. Of Q&A time, because I know a bunch of you are probably on here because you have a burning question going on your particular project that you want answered. And Brian, if you're listening in the background, why don't you push that poll for me right now, brother? I am curious if you would, guys, we've got a poll here. How many of you really are in the 3 categories? Are you a builder interested in kind of learning more about your future houses and which direction to go for your HVAC systems or HVAC plus D that we're particularly talking about today? How many of you are a homeowner that's also trying to solve a problem? And some of you maybe both. I know I was that builder trying to solve my personal problem at one time. How many of you are in the trades? And how many of you are potentially building a dream home? And I would put you under the homeowner category as well, that you're really trying to make sure that you do everything right, know all the correct things so that when you build that house. So if you take that poll, it should be on your screen under attendee poll and click that button. I'm curious to know the results. And again, the Q&A tab is going to be the best place to drop those Q&As. I already see Sankit already put a good one in there. So please throw your Q&A. We're going to leave some time at the end. But let's introduce the other hosts that I have with me. So first up, Nikki Krueger. Nikki and I have been friends for probably going on 10 years now, I bet, Nikki. Is that right? Have you been with Thermistore for 10 years, Nikki?
I have been there 12 years, and I just randomly came across one of your videos probably about 10 years ago.
That's awesome. So if you don't know Nikki's company, Thermistore is the parent company to Santa Fe. She's coming to you from a crawl space where she's actually underground, and she's buried in the dirt in that crawl space to show you the Santa Fe in the background. Thermistore is the parent company to the brands that you already probably know, which one of them is Ultra-Aire that I've been using for going on 10 years now, and almost every house I've ever built in the last 10 years. Santa Fe is their line of dehumidifiers that's really intended for crawl spaces. And then they have several other lines, including people that are in the growing industry and people in commercial dehumidifier, all kinds of different options out there. But Thermistore, really the 2 brands that you would most interact with if you're on the webinar is Santa Fe and Ultra-Aire. Did I miss anything, Nikki, on your intro?
No, that's perfect.
Okay, good deal. And then Steve Baczek. Steve, man, Steve is one of the smartest men I know, let alone the smartest architect, the smartest builder. Steve has more knowledge up there behind that puffy gray hair that he's looking a little unkept today than normal.
I'm bringing the
then-
Einstein back.
I
New
like it,
haircut.
Steve. I like it. Steve,
So-
man, not to pump your tires, but man, I've learned so much from you over the years, and I am really, really thankful that Steve helped me with my details for my house under construction. We're at my home, and a little bit later, I'm going to go rogue and take my phone out and show you a few things from my house under construction, including what we're talking about today, and some of Steve's details. And Steve's going to answer some questions that I think some of you may be asking, which is really from the more cold climate perspective. Why and where and when might you use some dehumidification? I'm really kind of the poster child for the need for dehumidification. It's a little more obvious in the hot, humid South, but Steve's got a lot of experience with it up in the, he's actually in the Boston area, but builds houses and has designed houses all over the country and even out of the country. Did I miss anything on your bio there, Steve?
Nope. All sounds good, brother. Thank you.
Okay, good deal. Well, guys, let's transition. I'm going to go ahead and do screen share. I've got about a 15-minute presentation to show that I wanted to show you. That's kind of my story and my history from this perspective. So let me switch to PowerPoints. I'm going to hit share here. And let's see if I might need to go to my PowerPoint app to make sure this is sharing correctly. Okay, yeah, we're good. Oops, how do I go back? Sorry, y'all. Okay, so for today, there's really kind of 4 things we're going to be talking about. And again, if you're joining us late, if you've got questions as I'm talking, throw that up in the Q&A. I'm already seeing 4 good questions up there. Thank you guys for doing those. We're going to leave plenty of time for Q&A time. We're going to talk a little bit about water and building materials. We're going to talk about building envelopes, mechanical systems, and what really is there a need for in terms of dehumidification. So how do I get to my next slide? There we go. So of course, water, as we all know, has 3 forms. And those 3 forms, when it comes to our houses, means that we've got moisture in our buildings. Sometimes that's just from construction. Sometimes that's from occupants. And sometimes that's from building materials themselves. So if you look at the kind of relative ratio of these, and by the way, this is a slide that my buddy Christoph Irwin shared with me. So thank you, Christoph, if you're on. There's an interesting kind of ratio here that this slide, when I first saw Christoph present, it really hit me. We're talking about relatively large numbers when we think about the structure, drywall, coverings, really that moisture that's bound up into our buildings. But when we think about it, humidity in our air, it's really not that many pounds of moisture. And so when we build brand new houses like I am right here, we have a ton of moisture, literally, 1,200 pounds, almost a ton worth of moisture bound up in our building materials. And then we also bring in our furnishings and all our other things. And as you know, most houses over the first year settle, drywall cracks, things change and move. A lot of that is because that moisture is coming out of our buildings and is drying. And we do our best to dehumidify during construction, actually quite a bit here in the South. In fact, I use another brand that we're not talking about today from Nikki's company called Quest for a lot of my under construction dehumidification. But there's quite a bit of moisture. Now, that moisture, though, that's in the buildings, though, has changed quite a bit. And this, I've heard Joe Stieberg talk about this before, that, when we were building in the 50s, our buildings would hold quite a lot of gallons of water, which meant that when a window leaked, there was a lot to soak up, right? We had real shiplap sheathing back then, not as I like to joke, the Chip and Joanna shiplap, but like real deal shiplap that was holding our structure up. We had real 2x4s. And these days, like my house under construction, you can see my engineered floor joists right here. I also have engineered studs, which means that my hydric buffer capacity, my ability to soak up water, is quite a bit less than it was had I built this house 50, even 20 years ago. Now we're talking about HVAC systems today. And what is an HVAC system for a house? It's really a functional system. And we're going to be talking about HVAC plus D. These are all the components of the mechanical systems that go into our house. But between the mechanical systems and the house together, we need to think about that from a building science perspective. And that HVAC system has to deliver a couple of key things for us, right? We think of comfort, number one, because we don't want to call back, we don't want a complaint from a client. But it's also got to help deliver some durability to the house. It's got to take some of that moisture load, whether it's occupant load or load from the drywall mud or the foundation that's still curing, and give us durability. It's also got to limit and inhibit mold growth and other activity that happens at higher moisture levels. It's got to deliver us a safe and also efficient HVAC system. Now, when we think about HVAC, the AC, air conditioning, is not just strictly cooling, right? It's not just a meat locker that we're turning our houses into. Cooling also has dehumidification. And when we look at the manual J's for our houses, the loads on our house, the manual J is broken up into two parts when it comes to cooling. There's sensible loads and there's latent loads. And when we think about just our thermostat in the house, that only tells part of the story. That's the sensible temperature. But there's also that latent load, and that's a big deal, especially for me in the South, because there's lots and lots of days where it's not particularly hot outside, meaning the sensible temperature, the sensible load of my house is not that big. But the latent load, that's the moisture that's locked up in the air, can be giant. And in fact, we have that all the time, even in December here in Texas, where just a week ago, I was not only wearing a coat, but I was wearing a t-shirt. And it was 80 degrees and 80% humidity out on multiple mornings in a row, even in November, December. You think of that as being a fall issue, but that can be the winter for us as well. And so that dehumidification is a big part of what's happening with the air conditioning system. Now, how does a dehumidifier work? We all know this. I'm preaching to the choir here if you're on this webinar, but basically it's a cool condensing surface, just like your air conditioner has an A coil inside of it. And that A coil has Freon running to it, which makes it really cold. Usually the A coil in your air conditioner is like 50 degrees or so. The air passes through that air coil, and just like you see on the right, it condenses. Now, it takes enough time for that air to pass through before that condensation occurs. But if the A coil on your air conditioner isn't cold enough for long enough, we need that water to actually drip off of that coil and go down the drain before dehumidification actually happens. And one of the big problems that I've talked about for years is that we over air condition our houses, meaning we size our air conditioners too big, which means that the house can satisfy the cooling, the sensible loads, often very, very quickly. In fact, my own house has this problem. My current house that I remodeled 15 years ago, it only takes, especially in the fall and spring, a few minutes for me to go from 75 down to 74, let's say, which is the set point on my thermostat, which means that none of that water ends up dripping down the drain and dehumidification doesn't happen. And remember that dehumidification only happens when that water is dripping down the drain. And so my thermostat, no problem, can keep up with the temperature, but in the spring and the fall especially, they do not run long enough to actually get much dehumidification in my system. There's a lot of reasons for that. We're going to get into that in a minute. But basically, when we design our systems, our HVAC systems for our houses, we're designing for that design temperature, which is really kind of an extreme load. The design temperature for Austin, Texas is 100 degrees. And that amount of time, the number of hours per year that it's actually 100 degrees out in Austin that my HVAC system is sized for is actually 1%. So that means 1 hour out of every 100 do I need equipment that's really going to deliver enough tonnage to satisfy that load. But most of the time, 99% of the time, I'm at what they call part load conditions, which means that it's 90 degrees, 89 degrees, 85 degrees. And I don't need my full capacity of whatever tonnage my air conditioner is. At my house across the street, I'm at my new house, but at my current house, I'm a 4-ton system for a 2,100 and change house. So I've got about 500 square feet to the ton, which I probably need in a not super efficient house that I remodeled 15 years ago, maybe closer to 2% of the time. But that still leaves 98% of the time that I've got too big of an air conditioner. And I'm going to tell you some stories about that in a minute. But the point here is we're under part load conditions a good majority of the time. And if you look at the temperature curve, just for my city alone, let alone your city, the temperature high lows, they vary quite a bit. And again, we're just trying to get that very top peak is where we end up sizing our equipment for when it comes to our HVAC equipment. And Nikki joked about the psychrometric chart. I'm not qualified to actually talk about the psychrometric chart. Steve probably is, but this slide shows you over the course of the year, how many hours am I at the different relative humidity and dew points in Austin, Texas over the course of 1 year. And it's crazy to think how varied the conditions are over the course of the year. Now, we've talked about this before. This isn't a VRF seminar, but just briefly, most equipment for HVAC systems is what they call single speed equipment, meaning it's either off or it's running at full speed. So like my 4-ton system across the street that's was just 2 or 3 years old when I bought my house and I didn't replace it. That's a single speed 4-ton system, which means that I now have either off or on as my options. Now, often people will talk about 2-speed systems or 2-stage air conditioners. And there's a couple different types. I don't want to go into all the details, but basically there's some version of this chart you see in the middle there where there is some middle point. You know, they're off, they're on like half percent, 50%, or they're at full capacity, or there's like a 2/3 option as well. Now, the VRF equipment that I started looking at about 10 years ago, which is Mitsubishi, Daikin, LG, really almost all the manufacturers overseas have been doing this since the oil crisis in the 70s. The American manufacturers are they've been doing it for a while now as well. But we're a little behind because we didn't kind of run with that technology. And so they've got what they call variable capacity equipment, which means that some of their equipment can go down to as little as 10% capacity and ramp all the way up to 100% in those various capacities. And Mitsubishi, which I tend to use the most these days, does a really good job of that. Now, here's the scoop with Mitsubishi, and they've changed their marketing tune, I would say, quite a bit over the years. But when you have one of these big boys outside, that's a variable capacity condenser outside. LG and Daikin make really, really similar units as well. There's lots of good equipment out there. And of course, Carrier makes Greenspeed, Trane makes these as well. There's other equipment, but they're tied on the inside to various equipment that's going to run at various loads. Oops, I went too far ahead. Sorry, I'm gonna come back to that in 1 second. I want to flip to one slide here. So here's my very first install of a VRF system. This is a Mitsubishi system at an architect's house that's a good friend. He and I both were psyched to use it. We read all the marketing literature and felt like we don't need any supplemental dehumidification. This unit is going to do it all. And oh, by the way, this house is a 2-story house, one upflow box. You can see there's 2 return grills in the bottom there, and then it flows up. And it wasn't all that long after he moved in that he called me and said, "Hey, Matt, this just isn't doing what the literature told me it was going to do. You know, it has dehumidification mode right here in the thermostat. I think that it's supposed to run on a slow speed." So we had John Clark, who's my local kind of Mitsubishi guru, out. You know, we hooked the thing up to all the computers. I mean, these things are like Priuses. You know, they're all kinds of technology. And even though we're still using refrigerant, it's a whole different machine than that single speed unit that I have at my house. A lot of electronics. And these 2 guys are trying to figure it out. Meanwhile, look what's on the left of Bert, my HVAC contractor there. See that little gray box right there? The homeowner, in the meantime, had gone out to Lowe's and bought a little $300 standalone dehumidifier because he felt like he was getting the cooling loads he needed, but he wasn't getting that dehumidification that was promised by this VRF technology that we were so bought into. So we went out and bought that. So here we spent probably, I don't know, 3 different full days trying to figure out, is the equipment not working? What's wrong? Is the loads correct? Is the, what's the issue? Is there enough Freon on the line? All this stuff. And you know what it came down to? We just felt like the equipment wasn't able to do what the marketing told us it was going to do. And so there's a picture of his final dehumidifier install at his house, which is in a little closet right next to his unit. And this is about 10 years ago. And it was at that point that I said, look, I'm not going to make this mistake again, especially in a really expensive house with a homeowner who is less good friends with me. I'm going to start using Ultra-Aires in my house. And so now I have an HVAC system that can do heating, ventilation, and cooling, but I also have a separate dehumidifier. And about the same time at my own personal house, I was experimenting with this plug-in dehumidifier as well. And this is actually my kid's bathroom at my house, where I just had a $300 LG unit that, again, I bought at Lowe's. And I was dumping it every morning and every night and trying to figure out, does this make a difference in my comfort? Like, what temperature could I live at the thermostat if I have humidity under control and my air conditioner isn't strictly doing humidity control? And what I learned after living with this thing for a whole year just about was that, man, I'm actually comfortable, very comfortable at 74, 75, 76 degrees Fahrenheit, but I've got my humidity under control with a separate dehumidifier. Now, this is not an elegant solution. I had to dump it all the time. It was noisy. It was hot in my hallway in my kids' room, but it really gave me enough kind of mental understanding of these principles that I was learning to go, you know what, this makes a lot of sense to have a whole separate dehumidifier. The other thing that kind of made me kind of think back and remember in my lifetime is I actually grew up a Yankee. I'm from Pennsylvania. I married a Texas girl. I've been in Texas 15 years. I try not to tell anybody that I'm not native to Texas. It's not good for business. But when I met my wife 20 years ago, I noticed she'd always go out of the house with a sweater on, even in July. And why is that? Because we go to restaurants, we go to movie theaters. It's freaking freezing all the time. Why is that? Because the only way we can control our humidity is through this thermostat that's really not telling you a thing about what the humidity or the comfort in the house is. It's strictly telling you what the temperature is. So this is, again, about 10 years ago. What did I start doing? What have I changed to today? I've really gone to specifying an Ultra-Aire in all my houses, so that, like this install, which is one of my first ones that I really did, where it was designed and engineered, thought about ahead of time, it's part of my system. So what you're looking at here is 2 horizontally mounted VRF systems from Mitsubishi. I've got good filtration on the right there, good media cabinet filtration. And in the left, I've got an Ultra-Aire 90H ducted into the house. There's a bunch of different options about ducting, and we can get into that or not, depending on how much you want to get into. But ever since this house, I put one in every house. And sometimes I'll put multiples in. Like, here's a house I just completed recently that has a low static or medium static pressure ducted, and it's got a 70H. And later I'm going to show you my house. My house is actually pretty darn similar to this, where I've done, I don't have any high static pressure boxes because my loads are really low. I've got a very high performance house under construction. So as a result, I've got just 2 small, the smallest units they make, minus the in-wall version, that is, of these Ultra-Aire 70H. Now that 70H stands for 70 pints in a 24-hour period, which means that I've got, between the two of them, I actually have 140. I had to do the math in my head. I can't believe it took me an extra second. I'm sorry. 140 pints available of dehumidification over 24 hours.
Well, Matt, we can talk about that a little bit, just so everybody understands that that's rated at 80 degrees and 60% relative humidity.
That's right. Good point.
So that's the standard that the EPA tests to. So when the temperature goes down a little bit, you'll get a little less capacity. But that's when you look at dehumidifiers, they're all rated at the same rating.
Yep. Good point. Good point.
A little bit less, but still, I mean, you're going to get the most amount of dehumidification from a commercial dehumidifier.
Yeah, great point. And these two slides I kind of skipped by because I wanted to get to the story of my house. But one of the other issues that we're facing as builders and architects these days is our houses, our buildings have even less hydric buffer capacity than they even did a couple of years ago. Like in Texas, barn dominiums are super popular these days, which is basically a steel building with a steel skin and spray foam on the inside, like that picture on the top right there. Think about the hydric buffer capacity of that. How much moisture is that steel going to absorb? Basically none. So the hydric buffer capacity on this is some spray foam that could absorb a little bit and some drywall, and that's it. And then we're using so much engineered lumber these days. Same thing. How much is that LSL or LVL beam going to absorb from a moisture perspective? Very, very little. So that means that we really need to pay attention to the moisture loads in our buildings, so that our hardwoods are not expanding and contracting, so that our buildings are not experiencing massive cracks and other issues in that first year as they lose all that moisture. There's so much to talk about on this setup. Here's one of the options for an Ultra-Aire and how to actually plumb it into your system. I'm not going to spend a bunch of time on this right now, though, because I actually, in the interest of time, want to switch over to Nikki. And Nikki, let me pull your slides up to talk a little bit about Ultra-Aire solutions and how they can work and the need for those in your houses. So Nikki, take it away, and I'll be your Vanna White. So you tell me when you're ready for the next slide.
Well, really, we want to make sure that we're addressing humidity for the entire home. So, more than 50% of the homes in the U.S. are built on a crawl space or a basement. So if you're in a green grass climate, you might just need a basement or crawl space dehumidifier, or you might need a whole house, but there's a lot of reasons we need dedicated dehumidification. That's comfort, health, and of course the property protection. You've already covered, we're going into a lot of partial loads in even, just regular code built homes, because even code built homes are getting tighter and tighter. But when we get into these high performance homes, the whole goal is to try to run our HVAC systems as little as possible. They're the largest use of energy in our homes. So the goal when we construct these high performance home and even code built homes is to reduce that energy load. So we're seeing a lot less run times, even, in hot, humid climates. You'll see some homes with no loads, very little loads, but still, how do we address the moisture? Basements and crawl spaces we talked about. The other thing is we can't control human behavior. How you run a thermostat is going to be very different on how I run my thermostat. So if we're counting on people to run that thermostat based on 75 degrees, that might not happen. And so we might not get those run times. And really, whether it's a basement, a crawl space, an encapsulated attic, the whole house, using supplemental dehumidification is the only way to truly ensure 50% relative humidity. And there's a lot of reasons for high humidities in homes. This actually came from an email that I put together about a home in New Hampshire that was a high performance, low load home. And there was all these things basically going on in those homes. I mean, it was a tight house. We had construction drying, lots of wood. They had actually musical instruments that they were very concerned about. And it was all these things were adding up. And the reality is there wasn't a lot they could do at this point to try to change anything, but adding supplemental dehumidification was going to help all these things. So we had basements to deal with, and we had a wood construction house. So they didn't need a lot of dehumidification, but they did need some to get them to that safe zone. And this we just really talked about is, we're getting tighter and tighter. Which is really good to save energy, but unfortunately, no good deed goes unpunished. And so while we're reducing our sensible loads, unfortunately, we still need something to deal with the moisture in the homes.
For sure.
So this is from Indoor Air Plus. This is their new updated. So they have always recommended supplemental dehumidification I think it went up to climate zone 3. Now they're going up to climate zone 4. And they're actually not just saying a dehumidifier, but they are saying whole home dehumidifiers. Or again, you can use the controls to control the HVAC system, but you want to be careful with that, because if you overcool to dehumidify, you just never know where you could potentially create condensation.
For sure, for sure.
And then dehumidification, again, there are different code ways to condition a crawl space, but really the only thing you want to do in a crawl space or basement is dehumidify it for the most part. They don't need heating and cooling if they're encapsulated and the envelope's good. But they really now are adding these advisories where they're saying, they do recommend supplemental standalone dehumidification in those areas.
Yep.
So Advanced Energy has done a lot of studies out there on crawl spaces, and there's 75 million existing crawl spaces in this country, and about 250,000 new homes are built on crawl spaces a year. And we're getting now where builders are automatically encapsulating their crawl spaces out of the gate. The building science is showing the benefits of doing that, and the reduction in callbacks for issues for builders, especially if there's wood floors in those homes, a lot of wood cabinets, that sort of thing, that you need to control that moisture. But we're also seeing, a lot of homes now being built on going to be built on slabs. So we've got to think about how we're going to control that moisture in these homes.
Mm-hmm.
So typical green grass climate, we have relative humidity in basements about 65 to 75%. It's cooler spaces, the relative humidity is going to be higher. It's just, that's the way the thermodynamics works. You reduce the temperature, the RH goes up. Now, we've seen lots of different logos here for this Ultra-Aire brand. You took us way back to when you started using us. And then we had, this is the current logo that we're super proud of. It definitely, I think, has been updated and looks really great. But this is to show that we go everything from 33 pints, which is that in-wall dehumidifier.
Yeah, on the far left there, that's a cool unit.
Yep, and then all the way up to that SD12, which is that split system where you get some cooling as a byproduct. But really, depending on your application, the size of your house, we do have a unit that fits all ranges of applications, even commercial. We've been using a lot of commercial applications as well.
Love it. And
then Santa Fe, we've got our small unit here on the left, the Compact 70. Really, that's great for tight spaces. It's, when we get in those crawl spaces with not a lot of room, that works great. Then we go up to the next level, the 90 and the 120. These have dual exhaust, which is perfect for crawl spaces and basements, because you get that air moving, which is super important. And then our classic, which is our tried and true basement unit. Next. Thank you.
Sorry. I had to say goodbye to my plumber on the job site.
That's okay. So, it's important that we invented whole house ventilating dehumidifiers. The gentleman's Ken Gehring. He just did a great podcast with our friend Christopher when Ken's 82 years old, invented the Ultra-Aire whole house ventilating dehumidifier. Actually the first horizontal dehumidifiers for crawl spaces as well. So we really are the industry leaders and innovators with the most options and the longest warranty in the industry. We have a 6-year warranty, and that's really important. I think when we think about, like you were showing those portables, that's like buying a portable air conditioner to stick into a window as a temporary solution and one of those portables. If you're looking for long-term, that's commercial quality, that's designed to run in cool spaces like basements and crawl spaces, you want something that's going to come with that warranty and is built for that. So MERV 13 filtration and all of our dehumidifiers, super important right now. We're hearing a lot about filtration. You can do ventilation with that Ultra-Aire. but made in Madison, Wisconsin. That's where our
That is
factory
pretty cool.
is.
That is pretty cool. Thank you, Nikki.
Yep.
Steve, we've shut you out for the first
No,
half
that's
of
all
the
right, man.
webinar. Sorry, dude.
I'm listening along. It's all good stuff. All good stuff.
So Steve, I don't know that everybody knows your full background, but basically when Steve got out of architecture school, he spent a decade working with Joe Stiebrick at Building Science Corporation. And a good portion of what Steve was doing in the early part of his career was nothing but building failures and kind of figuring out where the problems came from. And Steve, with that background, give us a couple minutes on your take on dehumidification, moisture control through the mechanical systems in residential houses.
Yeah, I mean, you had put up a couple slides there. Certainly construction moisture is a huge one, especially today. Our construction schedules are very fast and very tight. Like we're trying to close in our buildings really quick. And so that means that construction moisture doesn't leach out like it would normally in your typical energy pig of a house. I consulted on a house. Listen, I have to tell this story because it is a funny one. And it had a basement. The basement was 350 feet long. It varied in width from 40 to 80 feet. It was 16 feet tall with 16-inch thick concrete walls with a 12-inch slab. And the builder was going to have it framed and closed in less than 3 months. Okay. So I told the builder, I said, my concern there would be how, you have to run some kind of system and get rid of that moisture. Well, the architect on the lines said, where do you think all this moisture is coming from? And I was like, could it be maybe the 500 concrete trucks that have come to the site? Just maybe. I mean, it just shows that we don't really, to be able to really accept the idea that dehumidification is a problem, we have to understand where it comes from. And a lot of people don't really understand where it comes from. And, it's certainly climate driven, like you said, but it's also construction driven. But I've had cases up here in the Northeast too. We have, the oldest house I worked on up here was 1690. It was originally built. But we have, I have literally worked on probably 60 or 70 houses that have a stone basement wall that, a river runs through it, if you will.
Wow.
And so you have a lot of moisture load in just ground moisture coming up through these systems. And then of course, people go upstairs and they do a 300K remodel with all this beautiful millwork and kitchen cabinets. And you're basically putting it above a swimming pool.
Yeah.
And then they're wondering why they go downstairs and all of their boxes with Christmas decorations are moldy green in about 2 weeks. And they just don't understand. And the other thing too, I think, Peter Yost and I have had some conversations. And one of the things about moisture loads is versus water management from a leakage perspective. Leaks, you have to think of them as point loads, but moisture loads are uniformed loads. They're all around you that you have to deal with. So you can't just kind of zero in on a specific area. It's kind of dehumidifying the whole basement or whole house, but it's this whole solution. It's not a targeted solution like you're trying to target when you're dealing with water management because it's such a uniform load. I've used a number of the Santa Fe products in for those instances where we just have basements that they're either too hard to condition or deal with the moisture from a conditioning standpoint, that we just go in and we put dehumidification systems in there to handle those loads before they're able to go upstairs. But yeah, it can be a huge problem, certainly.
Good deal. Thank you, Steve. We've got I took too long on my presentation, Nikki. I'm sorry. we got 20 minutes left and we've got 347 questions. No, not quite that many, but we've got
and we're going to get to them all.
34.
Well, we have the Wizard of Oz in the background, Justin from Nikki's company, who's answered a bunch, but actually a couple of these answered might be good for us to talk about. So if y'all are cool, let's switch for 20 minutes and talk through quite a few of these questions. I think there's some really good ones from our attendees. And then also maybe as we're doing that, I'll switch to my phone and I'll take you guys out to my attic and show you a couple of the Ultra-Aire units that are installed at my house under construction. Benjamin's got a good question here for you, Steve. Can you explain the importance of vapor permeance in wall assemblies when the building is tight? How do we ensure proper drying to the interior, let's say in Texas, when you're building tight?
Yeah, so it's one of those things where, you know, and certainly everything that I learned, pretty much I learned from Joe, but he always had just a superb way of explaining things. You know, you never want to trap any level of moisture in any assembly, whether it's a floor. We've investigated floor problems in Louisiana where people put, linoleum floors on there and then they put bad insulation, and next thing you know, the moisture's dripping off the bottom of the subfloor there. But you always want to have the ability for that moisture to make it or dry either to the inside or outside, both directions. But more importantly, if it dries to the inside, you have to have a system that can take on that load, right? It's a uniform load, and depending on where you are in the country, that load might be handled by the AC unit, or you might have to have supplementary, whole house dehumidification to deal with. And I can tell you from designing, very high performance passive level homes, when it comes to conditioning them, one of the challenges is certainly distribution. The other challenge is we can get the cooling load down, the heating load way down, but one of the challenges is always getting the humidification load down. It's a challenge. And like you said, Matt, the difference of comfort when you look at a psychometric chart, it's probably, 3 to 5 degrees of temperature difference. And it's not that it's the cooler temperature, it's that the amount of moisture that air can hold in that temperature difference makes it far more uncomfortable. Yeah. It's really interesting. And the other thing is we've become babies in our old age. I'm sorry, but our tolerance level.
Me specifically, Steve?
Or well, no, I'm saying
all old people like me.
I'm saying in general, in that if you look at a psychometric chart for the Boston area, there's probably 10 days where AC is required for comfort, right? But what do we do up here? We fire that baby up around May 15th and we don't shut it off until October 1st.
Totally.
Right. And totally. So when I say we've become babies, meaning that our tolerance for comfort has severely narrowed. I mean, we have HVAC guys. Hey, the kid's bedroom upstairs is 3 degrees cooler than our bedroom down the hall. And it's like, okay. I remember as a kid going to my aunt's house and my mom saying, go to bed. And I'd say, Mom, it's like 1,000 degrees upstairs. And you get smacked up the backside of the head and say, of course it is. It's summer, stupid. It's hot outside.
Open a window.
Yeah.
Grab a fan.
You go upstairs. Yeah, you go upstairs. Yeah, you put a fan in there and all you do is get blown high humidity air on you.
Totally. Good stuff.
I think it's going to be interesting as well with what's going on in the current recommendations of adding filtration and more ventilation to our homes, and understanding that we're going to have to also deal when we bring in more outdoor air during certain times of the year, that we're putting loads in the homes that necessarily that system wasn't designed for, or now we have to design for them. There was just an article in the one of the HVAC trade publications that talked about not only are people spending money at home right now, renovations, equipment, but they're not just switching out their HVAC equipment, but they're seeing more higher end HVAC equipment being sold than ever before. And I think that's because people are looking for the indoor air quality accessories because they're become more aware of them.
No, 100%.
And their intolerance level, it's like, it's one thing when you can go to your office for 8 or 10 hours during the day, but now when you're sitting upstairs and you took that extra bedroom and now made it your home office, the whole idea of comfort is changing. The whole HVAC world is going to get turned
Absolutely.
upside down, because our tolerances are going to get even tighter than they were because of the amount of time we're spending in our homes.
And everybody's home generating moisture for longer periods. We're cooking, cleaning all of our meals practically at home. So there's been a big shift for sure. And
100%.
And I think our HVAC contracting trades and our builders are going to be looked to for more guidance on building healthy, comfortable homes than probably ever before.
Totally.
And to close out Benjamin's question, Benjamin, one of the other things to remember too is air leakage, right? If I can build control into any assembly, wall assembly, floor assembly, attic assembly, or ceiling, however, then that air that transfers from the outside to inside doesn't have the ability to bring in as much moisture because I'm not exchanging as much air, right? So it doesn't have that air train to ride in on. So, gaining control is building a really good house and then dealing with the residual loads that are left over.
Bringing in that
Yeah.
fresh air, knowing where it's coming from, filtering it, conditioning it, putting it where you want it to go.
Nikki, let me ask a question for you that I think I can probably answer as well, but I think is an important one. Would you address the stack, or how would you address the stack effect with humidity? I.e., if you have multiple levels, a 2 or even a 3-story house, where should your dehumidification be taking place? The top floor or the bottom floor? Question mark.
The most drastic stack effect we get in our homes is during the heating season. That's when our homes kind of, blow up like a hot air balloon, and all the hot air is trying to get to the cold air outside. So in the summertime or the humid time, when we're air conditioning our homes, we've got hot trying to get in and wet trying to go to dry. But if you've got a crawl space or basement, those are typically cooler places. And I would typically I start with monitoring, and then always putting a solution in the basement or crawl space, and then monitoring the rest of the home. Now, depending on the homeowner, maybe they just want to go ahead and dehumidify that entire home, but typically we'd still recommend one for the basement or crawl space separate, because everything's run different. People aren't necessarily living full time in a basement or crawl space. If they are, you've got even more dehumidification concerns. But I think we need to address those areas separately. But during the humid seasons, you're going to need a more below the house than you are above. Now, if you've got an encapsulated attic, you might have to think about some dedicated dehumidification up there as well. We have a lot of builders putting in spray foam homes, like a Ultra-Aire 70, just dedicated for that space upstairs, up in the attic.
You guys, hopefully you're not hearing the background noise of my neighbor's lawn equipment going. You guys okay on hearing me? Yep. Let me answer that question on stack effect too. And I think that was Steven who asked that. Moisture always moves from more to less. And when I started installing dehumidifiers in my houses as kind of a standard, I thought, well, I'm good to go with just one unit, almost no matter the size and shape of the house. The problem is not every house is the same. Houses are different when it comes to their airflow between the houses and how cut off they are. And the most visible example for me was really early on, like 2011, 12, when I started using them in all my houses. I built a house that was a 2-story house that kind of had a front bay and a back bay, and just one doorway that connected this kind of front area and back area of the house. And I just had one dehumidifier, and I realized that we were getting some mold growth on the ceiling drywall in basically the master bath area, which was obviously a higher humidity area. And ultimately, what I realized was that one dehumidifier was doing a great job of dehumidifying that portion of the house, but because there was so little airflow between those two portions of the house, that I really needed a second dehumidifier. The other thing that, so basically anytime I'm doing 2-story houses, bigger houses that are cut up, I'm typically speccing and using 2 smaller units so that I know I've got good dehumidification throughout the house, because you can't just rely on moisture movement through a 3,000 square foot, 4,000, 5,000 square foot house and just spec the biggest one you've got in one part of the house. It just doesn't work. The other thing that I would say is if you're going to use your Ultra-Aire unit for fresh air, which I did for many, many years, be really cautious if your client wants larger amounts of fresh air, especially if that fresh air coming in as a high humidity load, you can overwhelm your system. So, you know, if you go to Nikki's website, the Ultra-Aire website, it's going to show you sizing. And, you know, this unit does up to a 3,000 square foot house. And those are really generic ideas of a house, right? That's a one-story ranch house with lots of good airflow throughout the house. But when you start getting cut off, when you start adding, you know, like at my house, I have 4 kids that are opening the doors and windows all the time, going in and out of the house. I have all kinds of additional load conditions that the Ultra-Aire website general sizing doesn't account for. And then this became especially visible for me at a client's job recently, a really smart client of mine, where we had 2 small units installed because we knew we had a 3-story house, but he wanted a lot of fresh air. And he cranked up his fresh air system to basically bring in a small amount of fresh air all the time through his ERV. And ultimately what happened was we couldn't control his humidity in his master bedroom because he had the fresh air system cranked on high. He wanted, because of COVID, he wanted as much fresh air as he could all the time. And so we had this issue with basically just overwhelming the dehumidifier with more fresh air than we could possibly drop the moisture loads out of. So my point is, consider using smaller units and more of them. And in general, there's not a whole lot of penalty in my mind for going to a slightly bigger unit if you're concerned about capacity. So, you know, if you've got a single unit you're going to use and you think a 70H is going to do it, you might consider going up to the slightly bigger unit with a little bit more capacity, because there's not a lot of penalty with this equipment. You're not running a lot of amps with this equipment. And if you look at their website and really study the amp draw of each individual unit, and this one's Energy Star and this one isn't, it's such minute stuff that you look at that it's in the scheme of things in the long term, it really doesn't matter that much. And then ultimately, when you get to my house, before we lose time here, I've got like 8 minutes left. I'm going to switch from my computer here to my phone, and I'm going to show you a couple things on my system if we can. And while I'm switching, I'm going to give you, Nikki and Steve, one last question, and then we'll give a tour here. I thought this question from Alex that was a good one. Alex lives in an older house, a 1970s house, fairly standard HVAC system, and wants to install a whole house dehumidifier. His question is, how do you suggest installing it? Is it better to put it on its own system, or should he hook it into the ductwork? And should he hook fresh air into it as well? Nikki, why don't you take that, and then Steve, maybe you could jump into that too, and I'm going to switch to my phone here.
Not knowing anything about the HVAC equipment, typically our equipment is integrated if there's existing ductwork. So we have lots of recommended, we have a recommended install, but we have alternative installs on our website that you can go to, and you know, your HVAC contractor can look at as well to do that. And for the fresh air ventilation, you know, I was listening again today to Ken Gehring's podcast, and you know, we count on fresh air from the outside and we say a leaky house, but that means a wind has got to be blowing in order to get that fresh air. So I always recommend controlled fresh air ventilation when you have that option, because you don't know how much fresh air your house is getting, and if it's getting to every room in the house where people are living. So I would absolutely recommend the fresh air option with that. And just to go back to that a little bit, you get about a third of the total CFM of the unit for fresh air ventilation. So we get that question quite a bit. How much ventilation air can I get? So if you look at the CFM of the units, you will see that max that you can get from that unit is a third of the CFM.
I agree. Is Matt back with us? You know, one of the funny things when you say that comes to mind. Two things. One, I probably met Ken Gehring back in like 1995 was probably the first time I met him. But the interesting thing that I learned from a lawyer, no less, is that you never talk about things as fresh air, because he said,
yeah.
"Can you guarantee it?"
Yep.
Right.
Yep. Outdoor air.
You can bring outdoor air in, but you can't guarantee it's fresh. And you know, it's funny. There are, and this is very cautious, because I've investigated places where when we have air intakes, people will put them like on a second floor wall above a roof. And guess what? You get to smell the asphalt shingles all summer long.
Yeah.
I've had people install them in a band joist on the first floor, and you get to smell the cut green grass all summer long throughout your house.
Yeah.
So you have to be very careful where you put these things. And the easy place to put those vents sometimes is not the best place to put those vents.
And that's why the filtration is so important on that outdoor air system as well.
Yep. Totally agree. You in the attic there, buddy?
All right, I'm in the attic, y'all, and I totally forgot to bring my light. So we're going to use.
You should get one of those Ola lights or whatever it is, right?
I am using my Ola light, as a matter of fact, Steve. Okay, so first off, a little orientation to where we are. There's my attic hatch right there. We're in my attic, which is a traditionally framed attic with rafters. I've got a ton of rooftop insulation, and I'll be adding some rock wool in these bays. So I'm in the air-conditioned space. Really, really important to put your ductwork always in your conditioned space. I added a window because I thought it was so nice up here. My son wants a desk up in the attic. But here's my HVAC equipment. I actually have a video coming out with Mitsubishi where we're talking about this equipment. You'll see that probably around Christmas time. But my guys did a really, really nice job of doing all metal trunk lines. And then one of the things that I've learned over the years with lots of good building science talks is that if we run rigid metal and then transition to flex just in the last couple feet, I don't know if you can see that down there. I've got flex right there in the last, 6-7 feet. It kind of quiets down the air. And now I've got a really good delivery system that's going to get the air where it needs to go, but also be pretty quiet in the meantime. This is what they call a pair of pants plenum. If you can see that, that's coming off my medium static pressure Mitsubishi system here. And then here is my Ultra-Aire 70H that the guys mounted on a unistrut and a spring system. Here we go, if I can see that. Maybe that's better. No, it needs to be at the high setting. So that if there's just a little bit of vibration, it won't vibrate on the plywood below to my daughter's bedroom, which is below that. So I've got one here, and then as I mentioned earlier, I've got a second unit downstairs. So because my house is fairly split up between a, what am I like, 1,400 square feet down and 1,200 square feet up, something like that. Now I've got one unit that's just dedicated to my upstairs and one unit that's just dedicated to my downstairs. Steve or Nikki, any questions or anything that you saw that brings up questions on that?
That is one fantastic house, man.
Yeah, very impressive.
Huge thanks to you, Steve. I mean, all my air sealing details, almost all of them are ones that I've seen you and our buddy Jake Bruton do before, which is really your methods that Jake's implemented. But all my exterior insulation details, how I insulated my roof deck, how I installed my windows and integrated windows into foam, all that came from Steve's awesome leadership. And Steve's just an incredible thought leader in our industry. And I've seen him do things that have absolutely blown my mind and taken me.
Well, here's a big teaser. Wait till about April or May. You're going to see the killer bomber wall.
Oh, the killer both killer and bomber on the same
wait till you see this one I got in the works. This is I'm just throwing a big tease out there, but
I love it, Steve. I love it. Well, guys, we're just about wrapped up. I've got 1 minute to go. Big thanks to Nikki for putting this webinar on. I know a bunch of you had questions that we weren't able to get to, but I do want to thank the Wizard of Oz in the background, Justin, who's been answering a bunch of questions. He actually answered 38 questions for us, even though we
Wow.
only got to 4 or 5. And I answered maybe 6 or 7 while you guys were talking as well. For those of you that had another question and weren't able to get it answered, Nikki, is there a way to get a hold of you or your teammates at Ultra-Aire for specific sizing or questions, or just what do I do for this, or this?
Sure. Probably the best way is just to go through me, and I can make sure that they get to Justin's team. It would be N Krueger, Krueger at thermistore.com.
Will you spell Thermistor for us?
Thermastor.
Thermastore.com. And Krueger at thermastore.com. Nikki, thank you so much for all your friendship over the years.
And Matt, I put in the comment chats there. If somebody has questions, you can follow me on Instagram and then message me, and I'll do my best.
There you go, for sure. Steve, what's your Instagram account? I can't remember. It's
Steve Baczek Architect.
Steven or Steve?
It's funny. I think it's
Steven.
Baczek Architect.
Steve's laying down knowledge for you every day for free on Instagram, my friends. And he's really good at responding to comments and questions too. So, Steve, thank you for your leadership in our industry. And man, I probably did 10 things in my house that I've seen you and Steve do, or you and Jake do rather, in past projects y'all have worked on. So what a privilege to work with you on this house as well, man.
I can't wait to see it. I'll be down there at the end of January.
Looking forward to it. We'll have to shoot some videos. Guys, thank you for your support, for joining us for this webinar. Consider Ultra-Aire. They're a great company. They're still privately owned. They're in Wisconsin, making equipment in America. They have great service and great equipment, and I've used them successfully for about 10 years now in every one of my builds. So I really appreciate their support. Follow me on Twitter and Instagram. Otherwise, we'll see you next time. Oh, wait a minute. That's just for YouTube. I'm sorry. Bye, guys. Good to see y'all.
Bye.
Bye, y'all.
Thanks for coming. I'll see y'all soon.
Bye. Thanks.